So this is another typical problem on isometric projections. You just look at the views given here. So as I mentioned, views will be given with the first angle projection method, so that this out of these two views, you can easily understand this is going to be the front view and this one is the top view. Okay. Now, origin is given on the left side. So your whole length that will be going to be on right axis. Okay. Now just identify the maximum dimensions. How much is the length? Length is 75. Okay. 75 millimeters is the length. Height 40 millimeter. This one is the height. This is nothing but the length, and the width that is given 50. Width is given 50 millimeter. Okay. Now this is the step number 1, I can say. Step number 2, construct box, that is by using the maximum dimension length into height. Okay. So LHW, you can just take into account and get the box first. Okay. So to get the box, you first of all draw a line, horizontal line. You have to keep the space above horizontal line sufficient so that you can accommodate the maximum dimensions. Then mark any one point here. Suppose if you say this is the point, okay, name this point as a O, origin. Then as usual, as you know, in previous problems, what we have done, we have chosen the angle of 30 degree, both side 30 degree here, and there is one more 30 degree on left side, okay, through which we'll get the line 30 degree from O. This is the right axis. Even though you need not put that letter here, but just for explanation purpose, I'm just writing, even though sometimes even previous problem I have named the corners like 1, 2, 3, 4. Okay. But in actual answer, it is not must. Okay. Okay. Then through O, you can take vertical line, and that must be very perpendicular to horizontal line. How with the simple instrument, how can take it exactly perpendicular to this? Any one line. Hello. You just look at this. This is of sufficient length. So if you align with this horizontal line properly, just like your pro circle or protector, okay, you can get the exactly perpendicular line. Okay, I'm using this the using or handling the drawing instrument, that is a different skill. Okay, so I got this vertical axis. Now tell me on which axis are, apart from R, right and left, on which axis we have to take the length? Yes, anyone please?
Right axis.
R.
It will be on right axis. Why it is on right axis? See, O is here. Your whole length is on right side. Your length is on right side, so that on right side I will be taking the 75 millimeter. So I will get 75 millimeter on this right axis. Okay, so I got the point here for 75. Okay, then length obviously on width obviously on left axis. Okay, only height will be the on vertical one. So length width is 50. So I'll be getting that 50 here. I will get the point. Then this vertical line 40 millimeter from here. Okay. Vertical lines no matter. You just take it. You can erase. It is disturbing the view of your answer. Okay, right. Then through this point, height point from each axis, right and left, you draw the lines parallel to the same. I will be getting a line. This is nothing but parallel to right axis. Now I will be going to get the point line parallel to left axis. But handling of drawing instrument, it is very important. You have to have enough practice to handle it. So get a line for this. Once you'll get these 2 points, get the box, what you have to do, you take a line parallel to same line here, and you should move it further. You just adjust it and get the line passing through this point corner here, is going to be parallel to left axis. Now from this another point, you get a line parallel to right axis, and then you will get the box of length 75, width 50, and height 40 millimeter. Okay. So for sake of uh, comfort, I will just erase the extensions here so that you can understand this. The box is the boundary for your answer, not a single point is or a single surface or any part of your answer or object is going beyond this box. You did the boundary marking in orthographic projection. Similarly, here is the box marking. Okay. Once you will get this box, then you have to start with any one surface. How you able to do it, that is up to you. How you'll identify it. See, this is the slot for which you have projections here. So you can understand that this slot of whatever the length and the width, that is up to 15 millimeter height. Okay, so this is the 15 millimeter height. So what we'll do, we'll take the 15 millimeter from base. So of course, if you take it from even here or on this, also if you take it 15, no matter. You take a 15, have a point marking for 15. Okay, then draw a line parallel to right axis through this. Draw one light line. Okay, light line. You can easily understand that this from here it's the 25, then 25, and the remaining will be 25. Okay, then what you do, you'll be doing from here, you can take it for 25, 25, 25, as the length is 75. So see, this exactly 75 you are getting. So 25, then 50, and remaining will be the again 25. Okay. See, you can take the line from here, because we have to focus on this C part and this horizontal plate of 15 millimeter length. Okay. What we are going to do here, we'll draw a line because this is visible to you. Then draw another line passing through this point. And for this one, there is a slot of 15 millimeter width. So what we'll do, we'll adjust with the scale with the left axis, and we'll get the line of length, sorry, width, but in terms of measurement, it's a 15 millimeter. Okay, this is 15. So what I will do, I will be taking 15 millimeter from here. This is going to be the 15 point for 15. This one. Okay. So then you can get the point from here for this 15. You take it. Then now you can take the line parallel to left axis from here. You will get it. Okay. Now this is the slot you are going to get, but this edge will be visible as well as vertical edge. So what we'll do, from here corner, we'll take a line vertical parallel to vertical axis, and then we'll be taking the edge from this base. It intersect here. If you draw a line, because this edge is also visible to you, if you do it, because the slot is too wide in terms of length and width and even height, so you will get this line. Okay, I just making the unwanted lines either light, or I will erase it so that it will give the clarity to you. Okay. Okay, so this will give the clear image. Okay. If you convert it into the dark line, I'm just concentrating on the surface one by one so that you will realize how it is and why it is. I'm converting this line in thick line. So for presentation point of view and visibility point of view at your end, I'm making it with the pen, but you do not make it with pen. You just use the pencil, and that is enough. Okay. Right? This is the slot visible to you. Similarly, this edge is visible to you. This one edge is also visible to you. This part is visible. Right? Even this one is visible. Okay. Right? So you go step by step. Don't carry botheration about the whole thing. You identify the surface or the area and on which you have to concentrate. Now, okay. Now, once this part is done, see, this is the edge. Suppose if you take the left edge, this one, okay, the corresponding top view, this edge is throughout its width. So this one, and even from here you can get the line, you get it from here, right? Similarly, from right side, this edge is continuously there. So initially just try to get the very construction thin lines, okay, right? Even though if you just draw it, you can add the surface for 15 millimeter height plate. You just see that this is what the 15 millimeter height plate here, okay, and the remaining this part is your top. So what we will do here, you just look at this 20 millimeter, this 20 millimeter length. In top view, this 20 is here, this one for width 25 millimeter, and at the height 40 millimeter from base, 40 millimeter from base. So what we'll do, this is the width 25 millimeter and length 20. So what we'll do, we'll take the length 20 here first. Lengthwise, it's a 20. So we'll take the length, because you know that the length is on right axis. This is the right axis, okay, to which this right axis is parallel. So from here, and it is again from the end. So 20, we'll take it. Then we'll take the 25 millimeter from here. We'll take 25 millimeter. Okay. So this is the 25 by in terms of width. So what we'll do, we'll get the intersection of this at the top from this point. This is 15, sorry, 20. This is going to be the 25. This you just take it. Now you got this top, which is visible to you like a surface. Okay, surface A. Okay, I'm just making it intentionally dark because this is the visible line, or we can the outlines. Okay, now once you get A surface here, now the next part is to look at the B surface. For B and for B, this is inclined one, and at a 40 millimeter distance from one end, you are going to get from here 20 and then 40. Okay, so what you can do here, how much is this is 15, so remaining is 25. What we'll do, from here I will be going to take the 25 millimeter down, but before that just I will take it randomly and you will get it. Okay, so this will be the 25. So of course you are going to get it 25. So make it light, dark, sorry. Okay, and this you can join with. Okay, this you can join, but this edge is not there. Okay, I just going to remove it. Then on its surface here, from here itself, what I'm going to do it, just give me some time. Okay. And from this end, at a distance of 20, this is 40. So from here, I can take 40. So from this edge, I can take 40 millimeter. Forty. Okay. And then I'll be going to take it parallel to this. Remaining will be the 50 millimeter. Okay. Then I will join this point with top, because this is what given in problem. This surface, this is inclined. Similarly, this edge, it is inclined. Okay. If you draw this line, okay. If I erase the, or I just make it, going to make it light, some of the lines that are getting mixed with your surfaces, I'm just going to remove it. Okay. Then the remaining part you can make it dark. And this is going to give the complete answer by adding few lines here. We'll make it dark. All lines are there. Okay. I'm just going to join this last line here. Okay. And this is going to be the complete solution. You can even compare with, again, you just cross check whether you got the right isometric or not. Okay. Then later on, you can highlight some important dimensions here. Yeah, take the extensions. You can take the extension from here. For sake of dimension, you can take it. Even though you can take it like this, you can extend it. So wherever possible, you feel necessary, those dimensions you can give. This total is 75. This slot is of 25 millimeter. Height, you just adjust it. You can write 15. Similarly, for other surface too, you can have light lines, dimensional lines, bit extension beyond the boundaries, sufficiently, at least 5 millimeter spacing you should keep in your outline and the dimension line. This one, okay. Do not close, keep, take it close to, sorry, this is a 25. Okay. this 20, that also I can add here. But make sure that this dimension line must be parallel to the outline. This one. This is going to be the 20 millimeter. So likewise, few more addition you can do it. This 50. This is going to be 25. It is 40. So if you add this 25 along with this 15, that is fine. This distance is going to be the 15 millimeter because 40 plus 20, 60. So a total 55. You can cross check once for if dimensions missing. This is missing. Yes. It is for 15 millimeter. Okay. That's it. Height it is there. Width. So this is the complete answer now. So this is the simple problem. Front view and the side view. Okay. Front view and the side view. Now, as I mentioned you that two combinations are possible in isometric projection. Front view, top view, or front view, side view. Okay. This is the case in which the side view is in picture now. Okay. O is given here means if no mention here with the title front view top view means O will be always with the front view. Okay. But looking at this, can you identify the maximum dimensions here? Hello? Yes, please. How much is the height
Sir,
here?
where is O? I didn't understand.
Yes.
Where will the O be?
O is here. Okay, okay. Oh, sorry. Not visible to you. Okay. I will add
Okay, sir,
this.
got it.
I thought that it is visible, but you cleared it. Okay. This is the O, right? So this is the front view, and of course another view will be the side view because it is adjacent to each other. Okay. Now by looking at this, how much is the height? Yes, please. Height.
70,
Then length. How much is the length?
60,
Right. And the width.
20,
How much is the width? Yes. Okay. How much it is? This one. Okay. 20. Right. See. How you will get the length? Because the radius of this semicircle, it is given 30. So diameter becomes 60. So diameter 60 is going to be the length. Right. Now you will start with the next step. First of all, we will get the XY line. I will adjust it with space. Okay. Now I think yes, I can take the line here. Okay. So XY line, I will take any one point on this XY line. Say suppose this one, then through which I would take 30-degree, say O. I will take in this 30-degree on both sides. Then I will draw a line at an angle of 30-degree. Okay. This origin O, this angle is 30-degree. Okay. Then how much is the height? Height is 70. But first of all, I have to get the line perpendicular to this line, and this height is to be 70. Okay, 70, right? Height, length. In which direction we have to take the line length now? On right or left axis? Right or left? Yes.
Right axis.
Right. Right side, right? Because O is on left, so we'll be taking this 7 length is 60. We'll take 60 here. Width is 20. We will be taking this 20 here. Then with reference to this, we will get the box first. I will take it, align this edge with the vertical axis, and then I will take vertical line. Then again I will align with this. I will move the roller scale. Okay. Then I will align with left axis first. I will take it with the roller scale, and I will draw the line which is going to be parallel to left axis from the height point. Then I will take it parallel to right axis, and I will take it from here. Then I will continue with the same, and I will take one more line which is going to be parallel to next one. I will be taking it parallel to this. Then I will adjust with the left axis, align with the left axis, and I will going to take it from here. Now you will got the box. I will erase the unnecessary lines because it should not spoil the appearance of your answer, particularly in getting the box. So you will understand that this is the box within which you have to get your answer, right? Okay. Get the box first. I hope you are ready with this. Yes, are you ready?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Then look at the, now once box is ready, now you have to look at the front view and the side view. See, in a front view, there is a circle and semicircle. Corresponding to this circle, in side view, there is a dotted line, means there is a thorough hole for 20 millimeter width, right? This is very clear. Similarly, this semicircle, it is for this plate. Okay. So from this point of view, what you have to do? Your center of your circle is at a distance of 40 millimeter from bottom. So what we'll do? We'll take 40 millimeter from bottom. So remaining will be the 30. Okay. We'll mark the center first. Suppose from here, I will be taking 40. So this is going to give the center point. So do one thing through these two, draw a line that is going to be the center line, correct? So even you can use the notation as like a center line, long dash, short dash, long dash, short dash, long dash, short dash, long dash, right? So this kind of notation you can use. Similarly, the vertical center line that's supposed to be here. Okay, it will be like this. Okay, so center will be at 30 millimeter from here. Uh, Length is 60, so 30 millimeter from here. So this is 60. So at 30 millimeter, you will get the center. Okay. And through this center point, you're supposed to get the vertical center line. You can even draw a thin line also. Okay. Because here, thin line, maybe very thin line, you can take it. So this is going to be the center point according to this. I hope you've done it. Center line.
Yes, sir.
Okay. Now, what is the diameter of the circle? Say complete circle 360. It's a 40. Means radius is 20, right? So from center point on each axis, on each direction, all four directions, you have to, or four side, you have to take the 20 millimeter distance in compass. Okay. So better to take it in compass itself and locate the point. So you take a distance 20 millimeter in compass. This 20 you will be taking in compass, and then with this center have arc on all four sides. Okay, get the arc from center, means just arc on this vertical axis, two arcs, and horizontal axis, two arcs. Okay, you got these points, right? Then to these points you will be going to get the lines parallel to vertical axis through horizontal center line, and through vertical center line, horizontal lines. Okay, you align it with the vertical, and from this point you should get the line vertical. Similarly, From another center on horizontal line, center line, you should get the, okay. Then you align this roller scale edge with the horizontal center line and get the line passing through the arcs which is cutting the vertical center line. Through that point, you should get the line. Similarly, move the roller scale and get the bottom. And it will give the rhombus. You did the rhombus kind of drawing in plane. But here, rhombus, all sides are equal. Okay. Only the diagonal length will be different. Got it? Now we have a major diagonal and the minor diagonal. Right? Understood? You get it first. This is a very, very important. Okay. This length of all four sides will be 40 by 40. 40 millimeter, 40 millimeter, this 40 millimeter, 40 millimeter, because the diameter is 40. Okay. Diameter itself is 40 millimeter, right? Just wait. Now I will be taking the attendance. Okay. Ready? All of you?
Yes, sir.
Okay. Now the next, for just sake of understanding, I'm going to name the points. Okay. Suppose for midpoints on this line, I will say M1, M2, M3. Suppose M1 midpoint, M2, M3, and M4. Okay. For sake of just understanding, naming is not must at all. Now, diagonally of corners, I will name it as A, B, C, and D. Okay. Out of this, if I consider the diagonal, suppose if I draw a light line here, diagonal BD, okay, is less than diagonal AC. Okay, BD is so is shorter diagonal. Okay, understood? This shorter diagonal we have to choose for further steps. Okay. Yes, are you ready? I will make the diagonal lines light because not very important for us. Just for your understanding, I drawn it. Okay. Are you ready? Yes or no?
Yes, sir.
See, if anything is left, you will anyhow you are going to get the recording, so not to worry about that. Now you do one thing: join midpoints opposite to the shorter diagonal corners. Okay. For D point, which one is the opposite midpoint? Which two midpoints are there opposite to D? Respond. Hello. M1 and M2, right? So do one thing. Take M1, join D point with M1 and M2. Okay. Join M1 and M2. This is the line which I had drawn. Okay. D to M1 and D to M2. Okay. Similarly, from B, join opposite midpoints M4 and M3. Okay. Got it? Yes. Yes. Is it okay?
Yes, sir.
Now, intersection of this point here, intersection point, very important. We can name this intersection as C1, C2. Okay, C1, C2. This intersection point. Name this C1, C2 for sake of convenience. Okay. The next one, take a keep metal end of your rounder at D or B, anyone. You want the same complete circle here. So do one thing. You take a distance D to M2 and get the arc. If there will be some error in measurement, if you have done it perfectly, then definitely you are going to get it. You just adjust it partly if required. Okay. And get the arc, joining it with M1 with M2. If you have done it accurately, all parallel lines, perpendicular lines, then with B as a point, join M2 with M3. So change, maybe just manually, if it is if it is happening, if you are getting it exactly. I'm not getting the exact lines here, so that's why little mismatch. With B as the center, draw an arc joining M3 with M4. Okay. D as a center, radius D to M1, join till M2. With B as a center of your rounder, join M3 with M4. Little adjustment by millimeter, you can do it. Okay, it just adjust. Then what's next? I hope you've done this larger arc, two arcs. Yes? Yes or
Yes,
no?
sir.
Yes, sir.
Now, next, choose the C1 as a center. Take a radius C1 to M3 or M2 and get the arc. Okay. Again, here, if you want some adjustment, you can do it. Okay. Little here and there, you can adjust with that. Okay. Take that center, draw an arc. Getting this small arc, if the dimension is too less, it's quite difficult, but you try to get it. You just try to manage it. C1 as a center point. Okay. And get this arc. Similarly, C2 as a point, get arc joining this M1 with M2, okay, M4 with M1. Maybe partly you can do it major part with the compass and remaining one, if it is not matching, then you can do it, but it should look like a arc. Little adjustment you can do it manually. Okay, so this is the isometric circle. Isometric circle always look like a ellipse. Okay, understood? Major radius 2 arcs, minor radius with C1 and C2 center, this small 2 arcs. Okay, done it?
Yes, sir.
Okay, now you have to focus on the semicircle of radius 30. Okay, radius 30 with the same center, correct? So just for sake of convenience, what I am going to do, these construction lines or these points, I will make it bit light now, because similar construction again you have to have get the rhombus for this one. Okay, so what is the radius of that semicircle? 30 millimeter, correct? 30 millimeter is the radius, right? So take 30 millimeter in compass. So of course with this center you are going to get this 30, right? Because from here this is distance 30, but on bottom side I have to take it 30 now. Okay, now on all sides it is 30, right? So what we'll do, already remaining edges are there, I will adjust it uh, with the right axis, and I will get the rhombus, or I can say the isometric square. Okay, this is the isometric square actually. I will make it a bit dark so you can understand well. Later on I will erase it. Now getting your semicircle, this is now the isometric square. If I say, suppose if I say corner 1, 2, 3, and 4, correct? 1, 2, 3, 4. Your midpoints are already there. If I say midpoint M1, M2, this is the M3, and this is the M4, right? Okay, understood? You are getting the isometric square. 60 by 60. This 60, 60, 60, 60. Okay. Now, the shortest diagonal, which one is the shortest diagonal? 1, 3 or 2, 4? Which one is the shortest diagonal?
2, 4.
2, 4. So, join from 2, the midpoints opposite to 2. Then M4 and M3 through point 4, corner number 4. Intersection points here. Suppose if I say P1. So I will say P1. And the intersection of these two, it's a P2. Okay, P1 and P2. Now you want the semicircle starting through M1 and ends at M3. What it? This semicircle you want, not lower part, only semicircle. So how many arcs you required here? Out of for complete circle, 4 arcs, right? 2 with the major radius and 2 with the minor radius. For semicircle, 1 major radius, 1 minor radius. Okay. So with 2 as a center and radius 2 to M1, or we can say M2. Okay. This radius we have to take it. Are you with me? Hello? Yes? Are you ready? Should I wait? Yes? Are you ready?
Yes, sir.
Okay. Then keep metal end of your rounder at 2. Take a radius M2, here 2 to M2 or 2 to M1. If it is perfect, then you will going to get the arc. Draw arc. This must be the dark arc, out a thick line with thick line. Okay. This, okay. And then go to P1 point. Take a radius equal to P1 to M3 or M2. Okay. And get the arc. Okay. As I said, little adjustment here and there, you can do it. Okay. But if you are perfect in taking the parallel lines and the vertical lines, horizontal lines, then you should get the perfect arc. Okay. If you do not getting exactly, then manually, as in manual drawing, you can adjust it little. Okay. So this is the semicircle now. Okay. If I make the remaining lines light, definitely you will get the clear view of this minor diagonal. Sorry, semicircle. Okay. Understood?
Yes,
But
sir.
this is not the complete answer. Now the half back side of your plate, that is to be again converted into the semicircle and even this circle. Okay, but this is there for your reference now. Front side, you can take the reference of front half construction and you can complete the remaining half. Should I move to the next step? Hello.
Yes, sir.
Yes, sir.
Particularly for semicircle. Okay, which point you have used? I will just highlight it with the point M1, M2, M3, and 2, right? These 1, 2, 3, 4. These 4 points are important for you right now. Okay, understood? Just keep in your mind now what you are going to do. This semicircle is for 20 millimeter thickness, means you have to go back by 20 millimeters. So, of course, for these 2 points, of course, you will be reaching to the end. So, from this point, you draw a line from this point, so you will get the midpoint on back side, this one. Then you take the projection from here, project it M2 point. It will be getting, take the projection from M3 point even, take the projection from 2 point. Okay. But how much it is? For 20 millimeter distance, you will be taking it but you will go going back, particularly for these two cases, you have to go 20 millimeter. This is the 20. So I will mark the point, this 2 point, of course you are going to get here. Okay, even though I will mark the line here so that you can remember it. How much distance we have gone back? By 20 millimeter. Okay, this distance is of 20 millimeter from here. Okay, 20. Similarly, from here, take it for 20. Actually, it is not mandatory required here, but still, I will explain the procedure completely. This one is the point. So M3 becomes here now. If I say 2, and this point I will say 2 dash, right? 2 dash. Similarly, M3, I say M3 dash. Okay, M3 dash. This point to 20 millimeter back, I say 2 dash. This M1 I got here, I say M1 dash. This 2, M2, I say it's M2 dash. Okay, ready?
Yes, sir.
Okay, now once you are ready with this point, take a distance. Okay, from M, this T2, so 2 dash, you take a distance till M1 and you will get joining with M2. If you compare it, see how much distance we have taken. 2 to M1 distance, the same distance you are going to get it. See, 2 to 2 dash distance. So similarly, by backward movement of this 2 point, same distance you are going to get it. If you are accurate in procedure, you will going to get the same distance. Okay, right? So then I will draw the arc. I will be drawing this arc. Okay, get the arc from 2 dash in this direction, join M1 dash with M2 dash. Okay, done it. Yes or no? Have you done with the this arc?
Yes, sir.
Okay, now you know that for semicircle, one with the larger radius, another with the minor radius. Now you know that the center point which you have extended, uh, where is the intersection of that this diagonal with this one, this point? Okay, you are going to get the different point now. This one, P point. Sorry, I forget to tell you that I will have to extend the P1 point now. Okay, by 20 millimeter backward. Okay, I forget to tell you that 20 millimeter backward. I have to. By how much distance I will be going back? By 20 millimeter. Okay, 10 and 20. Now this is the this P point P1. So I can say this is a P1 dash point. Okay, P1 dash point, right? So from this point, I have gone 20 millimeter back. Okay. Now you will be taking the radius P1 to M2, the same distance you are going to get here. So you can take this distance P1 to M2, right? You have to take the distance P1 to M2 and draw a arc which is going to join with the M3. Okay. Are you getting this? So from here, I will be going to draw this arc. Understood? I will be just drawing the arc through this. Got it? With P1 dash as a center, and taking distance P1 dash to M2 dash, that will be the distance equal to P1 to M2. Okay. Have you got this arc? If done, let me know. So I will explain the last step now. Yes. Are you ready?
Yes, sir.
Yes, sir.
See, this arc and this arc zigzag, it is not possible. Okay. This kind of surface is not possible. It should be plane. So what we will do, we will draw a line tangent to this arc and this one. Okay. If you will get the tangent, you will realize how it is going to give the perfect view. Draw a line tangent to this. Okay. You understand what tangent. Okay. You draw it tangent, and then I will erase the anything which is done earlier. Okay. Now you will get the clear look of this. Okay. This small arc which I had done earlier, that is to be removed. Okay. And I must get this line, thick line. Okay. Now what I will do, I will make the visible nice now dark. This complete edge is visible height wise. From bottom to this radius center point, I'm getting the dark. Bottom line, it will be again dark. And this one, this part is going to be the thick line. Okay. Now you will get the clear image of this. Okay. This arc, semicircle. Okay. Got it? Hello?
Yes, sir.
Okay. Now, one more thing you have to add here. See, when the plate is kept inclined at an angle of 30 degree, means some surface of your inner surface of your hollow Thoros hole is visible to you, inner surface, right? If you keep it like this, suppose this is the pane. If you are looking at this from the front direction, this one, so only hole will be visible. But if I make this pane like this, means some of the surface will be visible to me. Okay, some of the surface will be visible. If it is exactly perpendicular, it's fine. But this is not exactly perpendicular because we have taken it in angle. Okay, so for that, this semicircle, what you do? Shift this B point particularly. Only one thing I suggest, take it parallel to this line, parallel to left axis. Go by 20 millimeter from B. Only thing which I want to add here, I will say this is the important point B, and this extension 20 millimeter back, I say B dash. Okay, B dash. And this length is how much it is? Remember, all movement we have done equal to thickness of that plate or the width of that plate, 20 millimeter. I needless to mention here 20 millimeter. Okay. or for 1 case, I have already mentioned here. So whatever backward movement, it will be by 20 millimeter. All those moments by 20 millimeter only. Okay, this is 20 millimeter. Now, for this arc, what we have done, we have taken the distance B to M4, B to M4 or M3, okay, whatever the distance, okay. Similarly, take same distance in compass, keep at B1, B dash, and draw an arc which is covering this circle, okay, which is going to cover this circle, okay. Till this age, you will be getting the semicircle, okay. And this will give the complete solution, okay. So wherever possible, I will just try to make the lines light. But what happens here, sometimes the very important lines are get light, so you have to do it carefully. So in at your end you can do it, because to showcase everything, some of the lines I have made it dark with some with pencil, okay, can't be erased, but you should understand the procedure and the important lines, and those lines should be remain dark, okay. Now this is the complete solution for it. Now, even though this box you can make it light, because it should not make impact, or it should not give the distorted view, okay. So it is better you just make the remaining lines very light, or make it, or just erase it, okay. Maybe partly or fully we can erase it, okay, right. I have tried to erase most of the lines which were possible to me, okay. Now this is the complete solution for this, okay. I will post the clear image of this question and answer on your group immediately after this lecture. And now I'm going to stop recording, and I'm going to end even today's session. So we had two sessions today, two lectures.